studied two-dimensional particle equilibrium problems earlier in this course. We saw this example shown here, where two men were placing a heavy crate supported by two cables on the floor. Here, all the forces, cable tensions, and the weight of the crate are all in the same plane. In this two-dimensional scenario, we have two unknowns and two equations. The unknowns are the cable tensions, and the two equations are the sum of all the forces along x-axis and the sum of all the forces along y-axis. Simple and straightforward. Many engineering problems can be solved using this two-dimensional particle equilibrium approach. However, there are problems that require three-dimensional analysis. Look at this hanging flower pot. We have a beautiful marble queen pothos here. Pay attention to the three cables supporting this pot, and you will realize that these cables and the forces associated with the cable are not in the same plane. In this situation, knowing the weight of the flower pot, we want to find the tensions in the three cables. So there are three unknowns, which means we need three equations. Since this is a three-dimensional problem, we can sum up all the forces along x, y, and z axis. The process for solving three-dimensional particle equilibrium problem is exactly the same as the two-dimensional problem. The only issue here is how do we find the projection of these forces onto x, y, and z axis? Well, this can be done in a few different ways depending upon what information is available. 1. Using the cosine value of the angle between the force and the x, y, and z axis. The second approach is using other available angles. And the third approach is using unit vectors. You can use whatever method is convenient for a given problem. Let's first look at each of these methods in the next video.